A study led by the University of Exeter has revealed that the Sahara Desert was once home to a megalake, probably formed more than 100,000 years ago. And Dr. Tim Barrows is from the University of Exeter. How did you find this out, Tim? What approach did you use?
It's been known for probably about 100 years that there's something strange about this stretch of the Nile in the eastern Sahara Desert south of Khartoum. The Nile River is much flatter and shallower than it is in the rest of the valley. So it's been speculated for a long time that there's maybe a lake or something in this area. So after satellite images were taken of the area, a colleague of mine found shorelines along the eastern side of the valley, sort of like what you'd see along the Carolina coast or Norfolk, which meant that there was a great deal of water in that stretch of the valley. So it must have been filled up with water at some stage.
We're talking, it's been described as a mega lake. What sort of size are we talking about here?
We're looking at about 45,000 square kilometres. So it would, if it was around today, it would probably be of the order of one of the four biggest lakes in the world.
Okay, fair size then. What's the whole cosmic ray exposure? How did that all work as part of the dating approach that you used?
It's been devilishly difficult to try to date these shorelines. Radiocarbon has been tried, but it was much older than radiocarbon can date, and a variety of other techniques have been tried without success. So we, at the University of Exeter, we work with a technique where we can look at the amount of exposure to cosmic rays from outer space. These are very high energy particles that are emitted out of exploding stars elsewhere in our galaxy. So they arrive at Earth at tremendous speeds and energy, and they hit rocks and sediment on the Earth's surface and actually split the atom and make exotic elements that otherwise wouldn't be around on Earth today. So by measuring the abundance of those elements, we can date how long the surface has been exposed for.
And this lake, when and why would it have formed?
It's a bit of a mystery to the first people that looked at this valley, because there's no obvious dam for the valley. There's sand dunes from the Sahara Desert creeping in from the left, and big alluvial fans from the Nubian mountains of southern Sudan. But there's no obvious blockage for the river there. So what we think is that the Blue Nile, which joins the White Nile a bit further north than this lake, was much bigger and carried a lot more water in the past than it does today, and it effectively formed a seasonal dam for the river and caused it to back up into a huge lake.
And why is it not there anymore?
So this particular time period that it formed in, we believe there was a much more intense monsoon than the area gets today. So the Sahara was much wetter than it was than we see today. So there would have been grasslands and all sorts of wildlife. You're familiar with the Serengeti wandering around where there are sand dunes today. And so it's that particular type of climate was when it was much warmer, probably about 2 degrees warmer than today. And so that caused a lot more precipitation and the big discharges on the rivers to form this lake.
Oh my God, the area would have looked completely different.
Absolutely. It's hard to imagine just how much wetter and it would have been.
How big a discovery is this as far as your own research is concerned?
We're very excited to be able to use exposure dating to be able to solve unusual problems like this, where we've got a situation where there's a slice of our history, our past, that's it's very difficult to understand without dating. So with our techniques, we've been able to put quite a precise age on it. So this tool provides a way of getting into the past and providing more of a contextual history to what we see out there in the landscape.
And what are you working on at the moment?
We're trying to date various places around the world where ice caps were much bigger and glaciers were much bigger in mountains and areas of Africa where there are no glaciers today, such as in Ethiopia and South Africa and Papua New Guinea, places you just wouldn't imagine there's ice today. But during the Ice Age, there were big glaciers there, and there's still a lot of mysteries around why there was so much ice in these tropical areas during the Ice Age.
You could actually draw up a completely different Earth, couldn't you? Because let's be honest, a 45-kilometre lake, 45,000-kilometre lake is going to make a massive difference, as we've already talked about, to that the way the Sahara would have looked at, 109,000 years ago. You're doing the ice caps as well. The Earth has evolved a lot, hasn't it, over those 100,000 or so years?
Yeah, those are really the extremes. The time when it was wetter was at the peak of a time period we call an interglacial, like the period we're in at the moment. So that time period was characterised by sea levels that were up to 6 metres higher than they are today. So if you go to Torquay today and walk along the beach or along parts of the south coast of Cornwall, you can see beach ridges well above the coast today. So some of the ice caps must have melted that we're familiar with today, like Greenland, in order to get that amount of water into the oceans. Whereas on the other side, when we've got big glaciers, sea levels were probably at least 120 metres lower and maybe as much as 130 metres lower. So no water between us and France, that's for sure.
And did you do all this based in a university lab, or did you actually get out to the Nile and the Sahara at any time?
Yeah, we went out and took the samples ourselves. It's quite an adventure. At the time we went out there, there's a civil war between North and South Sudan was fully taking place. So we could only go a certain distance south. There's some fantastic features we would have liked to have seen a bit further south, but unfortunately the area is quite unstable due to political unrest. So when we did get into the area, it was a very poor area, and we were quite lucky to find a quarry nearby where the owner of the quarry lent us his small son to go and get a bulldozer and come over and help us dig a 3-metre trench in order to look at the sediments. So we were very kind people. And so we collected the samples, and then we've got a lab here at the University of Exeter that specialises in looking at these particular isotopes that we set up a few years ago. So we extract the quartz out of the samples and analyse them on a machine called an accelerator, which blasts the atoms in the target we make at almost the speed of light to separate them and make an analysis so we can do the dating.
Could you tell when you were out there that you had something that was going to be quite exciting?
On the ground, it's a little bit hard to see because these beach ridges, they are anything up to half a kilometre wide. So you're sort of walking along, and there's a little bit of a change in the colour of the surface of a little bit of a rise. But it's only when you look from space that you can really, or from aerial photography, that you can really just see the sort of the magnitude of these features.
Fascinating stuff. Nice to talk to you. Thank you very much for joining us on the show today.
Thanks.
That's Dr. Tim Barrows from the University of Exeter.